Good day, fellow. So is back. Today we are going to do trigonometry. Trigonometry, to be specific, the two dimension. What do we mean by the term trigonometry? It's a branch of mathematics that deals with figures. Let me say shapes. Deals with shapes, size, the sides, and angles. This is a simple definition of what of trigonometry. Then now we have the term two dimension. Two dimension is a polygon which can be represented in a form of a plane. Normally it has what? The x and y. It can be represented in a form of x and y. That's a plane, a two dimension, like a square. It's a plane, a polygon. Then now as for today, we are going to focus mainly on sine rule, proof of sine rule, cosine rule, and area rule. Firstly, we are going to consider what? The sine rule. Let us do the proof of sine rule. Suppose if I have a triangle like this, and I have angle A, B, C. We need to prove that sine A over small a is equal to sine B lowercase b sine capital C lowercase c. We need to prove this formula. For us to prove this formula, we have to construct a height from the given triangle. We are going to construct an altitude, a perpendicular altitude. Let's call it h. Then now, if you were to look carefully from this given triangle, we are going to have two triangles. Honestly speaking, we are going to have three triangles. But now, let me name this one D. Then we are going to have a triangle ABD as well as CBD. You see, we have triangle ABD and triangle, let me put it here, triangle CBD. Do you see? Then now, what I'm going to do now, I'm going to name the sides opposite to the given angles. Then for BC, I'm going to write a small a. For AB, I'm going to write C, which is opposite to angle C. Then AC, which is going to be small b. But I'm not going to use it for this proof. Then it's fine. For us to prove the sine rule, we are going to consider angle A, angle B. Firstly, we are going to take the sine of A for this triangle ABD. We are going to take the sine of A. We all know that sine A is given by a ratio of opposite divided by hypotenuse. Then in our given triangle, our opposite is going to be H. Let's write H, which is BD somehow. H. Then your hypotenuse is going to be C. Then let us solve for H. We cross multiply, then we are going to get sine of A with H. Then now, let us do the same thing in triangle CBD. We have CBD, triangle CBD. Let us find the sine of C. The sine of C. Going to say sine of C, which is given by opposite, which is H, your BD, your H. Then your hypotenuse is going to be BC, which is A in this case. Then let's write A. From here, let us solve for H. You cross multiply by saying A multiplied by C, sine of C. You are going to get sine of A sine of C, which is equals to H. At this point, we can clearly see that both equation, let me say equation 1 and equation 2, they are both equals to H. Then we are going to equate them by saying we have sine C A, both they are equals to H. Then let us equate them, sine C. Why? Because both somehow they are equals to H. At this point, we'll start by dividing both sides by C. Then C cancels C. You are going to be left with sine A this side, with A sine C C. Then let us divide this A now, both sides. A cancels A. Then our final answer is going to be sine of A divided by A with sine of C over C. Bear this in mind. We have considered the angle of A and C. It will also be true if I were to take B and A, or B or C. Hence, from here, we are then going to add only sine B over small b. Then this is just the proof of what? Of sine rule. Then now, how do we apply sine rule? So simple. How do we apply sine rule? Sine rule. How are we going to apply sine rule? We only apply sine rule, ne? We only apply sine rule if only we have, let's say, triangle 1, you have angle, another angle plus sides. Somehow I should have 2 sides and 2 angles, 1 side, or I need to have 2 sides, sides with 1 angle, one side to 1 angle not included. It should not be here between these 2 angles. It can be here, it's fine, or here. Then it will represent not included angle. Let us consider a diagram. Let's say if I have a diagram like this, say somehow I have 30, maybe here I have, let's say 60. Say I have A, B, C. Then let's say this one, it's, let's say 30, let me say different number, 45. Then I ask you a question to determine, let's say to determine BC. Then let us go to our conditions. We have two conditions. First, the first one states I should have two angles on one side. It does apply. But this one at the moment, it doesn't apply because I only have one side. Then at this point, we are going to, for us to get the value of BC, we are going to use this strategy of drawing arrows like this. You see, by drawing arrows like this. At this point, we can clearly see that I have angle C and angle A, but not B. Then I'm going to use sine of A divided by, let's say side is BC. Don't use small letter a or lowercase a. No? Just use BC. Then we also have sine of C. This is our formula. And then AB. Side that is opposite to C is AB. Then now let us solve. The angle of A is 30 degrees. We divide BC. I don't have BC. Sine of A is 60 degrees. Do I have AB? Yes, it's 45. Then at this point, we are going to cross multiply. This one multiply, we are going to cross multiply like this. Then you are going to get 45 sine of 30 this side. Then you multiply BC with sine 60. You're going to get BC sine of 60 degrees. For us to find BC, we divide both sides by sine of 60. Then this cancel this one. Let us take our calculator. Take our calculator. 45 sine 30 divided by sine of 60. We get, we get 25. Our BC is going to be 25,98. Yeah. And our BC is going to be 25,98. You see? Then let's say the follow-up question says now find AC. Don't be afraid. AC. Then yeah, I'm going to erase this one. No? Then for us to find now AC, it's a continuation. It's a continuation. AC. AC, let me erase that, those arrows. Yeah. For us to find AC, you can clearly see that for us to get AC, we need that angle. We need that angle. Look, so simple. We know that if we add A, B plus C, we should get 180 degrees. Why? The sum of angles of a triangle. Then our A is 30 degrees. B, we don't have B. C is 60 degrees. It's equals to 180. Then we are going to get 90 B plus 90 degrees equals to 180 degrees. Let us take 90 to the other side. It's going to be 180 minus 90 degrees. Then your final answer for B is going to be 90. at this point our B is going to be 90 degrees. Oh, now we have angle B, we also have angle A and C. Let's go and calculate the side of AC. It's so simple. My advice is always use the givens. Always use the givens, like 60 with 45. You see, always use the givens. You can use this one, but in case to be on a safe side, use the givens. Then we are going to say C, this one goes with this one goes with this one. I hope you can see there. Then we are going to say sine of C, let me start with B divided by AC, CAC, we need AC. Then let's continue by saying sine of C divided by AB, yeah, AB. Then our B is 90, I'm going to say sine 90 degrees. I don't have AC, I do have angle C, which is 60 degrees. Then my AB is 45. Then at this point we cross multiply again, this with this. Then 45 sine of 90 degrees, we cross multiply AC with sine of 60. For us to find AC, we divide everything by sine of 60, sine of 60. Let's see. It's going to say 45 sine of 90 sine 60. We get, hopefully I substituted correctly, then we get 51 for AC, going to get 51,96. You see, this is a sine rule application of sine rule. Now we are going to move to the cosine rule. Now this was just the sine rule. Let us see the cosine rule now.